Hello, this is 11.1 Trig Identities. These are the questions that you have at least on your practice guide. There's 5 main basic identities that you should know, at least the ones that you should know for today. Here are your 5 main ones. Now there's a lot more than 5, but at least to kind of start this out, we're going to learn these 5. You'll get familiar with these 5 as you do these problems, okay? But again, you need to have these memorized as well. Now, when it comes to identities you've actually done before. Remember, if you remember polynomial identities, well, that's something that you've done before. You had to prove that one side is identical to the right side, and that's exactly what we're doing here. And that's exactly what you have in this case. It's telling you that these are identities. My left side is identical to my right side. Okay. Certain identities you know already. Like for example, I have tan theta is equal to, well, you know that identity, right? That's equal to 1 over cotan. Okay? So these types of identities you know already, we're just adding to that list, right? I'm going to focus, again, for these problems, you can, again, I encourage you to struggle on them. You're going to have to take your time, but if needed be, you can have help on the key. Okay. I'm going to start with 8, since this is really the focus on this chapter, or on this lesson. Right. When you do identities, again, I'm telling you, my left side is identical to my right side. Okay. It might not look like it, but you have to take some steps in order to prove it. Choose the side that's more complicated. So I'm going to choose the left side, right? I know my right side should be cosine cos x. I know my the left side should eventually be cos x as well. But I have to make sure I prove it within these steps. Your first, again, if you don't know what to do exactly, your best bet is probably to change things as much as you can in sine or cosine, right? So secant x I can change into 1 over cosine, right? So these steps will allow you to start developing your identity where you can prove your left side is identical to your right side. So that's exactly what I'll do. I know I have 1 plus cos x over 1 plus, now I'm going to change secant into 1 over cos x, right? Okay, well from here, I can go ahead and let's sort of clean this up a little bit, the denominator, okay? So what I can do here is I can go ahead and change 1 into, well, let me write the top part first. So I have 1 plus cos x, and I'll change 1 into cos x over cos x, because that's the same thing as 1. Okay, so again, I'm simplifying my fraction. I'm taking these small little steps in order to simplify this, right? Now I can kind of clear this up, right? I can make this into 1 fraction instead of it being 2 fractions, okay? So, I'll bring this over here. So, again, I have 1 plus cos x up top, and I have cos x plus 1 all over cos x, okay? So, again, we're getting somewhere, little by little, okay? Now you have basically a fraction divided by fraction, okay? So what you could do here is essentially you keep this first fraction, you change division into multiplication, and you flip your second fraction, okay? So that's exactly what I'll do. I know I have 1 plus cos x, again, I keep that. I'm going to change division into multiplication, so I'm multiplying. And now I'm going to flip this second fraction. So that means cos x over cos x plus 1. Okay. Alright, again, I can, let's see what we end up getting here. Again, there is a bit of trial and error, so keep that in mind. Sometimes one avenue will be blocked, so you might have to go in the other direction. So let's go ahead and multiply here, this top part. I'll end up having cos x plus cos squared x, and then all over cos x plus 1. Okay. So, again, we might be able to use identity here. I think the easiest thing we can do is we can end up factoring something out. Okay, so we can end up factoring something out here, because I can take cos x out. Okay, so I'm going to bring this up here now. I can factor out cos x, because what will end up happening is I'll have 1 plus cos x, and on the bottom I have cos x plus 1. Okay. Now you can already tell I can go ahead and start canceling this and this out since they're the same thing. And what I end up with is just cos x, which is exactly what I have on my right side. Okay. So how you want to finish this is you can finish this in multiple ways. But you simply just want to say, well, cos x, that's identical to my right hand side, okay? Just so, again, you can tell me that you're finished with your identity, or you can say proven at the end, okay? Now, again, these are small little steps that I took in order to solve for this identity, okay? But again, at the end, you just want to let me know, hey, Mr. Sharif, I've proven my left side is my left side is identical to my right side. Okay, so you want to give me some notification right at the end. Okay. All right, number 9. I've got 1 minus 2 sine squared. X is identical to 2 cos squared x minus 1. Now, it really doesn't matter which side you pick, since they're both equally difficult, I guess, or complicated. Usually you should pick the complicated side, but in this case they're about the same. Now let me, just a heads up, there's different ways you can do these problems. So your way might be a bit different from my way, but we should be along the same lines for the most part. I'm going to pick the right side, okay, and prove it to my left side. So I'm going to pick this side. But again, you could easily pick the left side since they're about equally challenging. Okay. So let's go ahead and do the right side and prove our left side. So I've got 2 cos squared x minus 1. So what I can do here, let me rewrite this. I've got 2 cos squared x minus 1. I can use one of my identities, right? Since if you notice, I need to have sine squared on the other side. Well, that brings up one of the identities that I should know already. That identity would be that sine squared x plus cosine squared x is equal to 1, right? That identity you should know already. Now, how can I use that to my advantage? I can simply, since I have cos squared x already here, I can say, hey, well, maybe I'm onto something. Let me see what cos squared x is actually equal to, and that way I can replace it and maybe get what my left side actually needs. So I can do minus sine squared x minus sine squared x. And what I end up with is cos squared x is equal to 1 minus sine squared x, right? So what I can do here is replace cos squared x with 1 minus sine squared x. So I have 2, and I'm going to replace this with 1 minus sine squared x. Okay? And then I'll start simplifying from here. Alright, so when I distribute, I should end up with 2 minus 2 sine squared x minus 1. Again, keep in mind what you have on this side. This is what I want to prove. 2 minus 1, you end up getting 1. Okay, so I end up with 1 minus 2 sine squared x. Well, congratulations. You have basically proved this identity where this is equivalent to my left-hand side. Okay, so this one is proven. Alright, number 10, I'm going to work on this left side. Okay, and I'm going to prove my right-hand side. Okay, so I'm going to use a bit of what we learned in the last problem. Okay, again, I need it to be equivalent to sine x. So what I can do with cosine squared x, well, that's an identity I'm familiar with. I can replace it with 1 minus sine squared x, right? So I have 1 minus okay, I'm going to replace cosine squared x with, again, 1 minus sine squared x. Okay? So what I can do now is I can start breaking 1 minus sine squared x down, right? That can be factored. So this can be factored into what? Well, let's find out. 1 minus, that can be factored into 1 minus sine squared, or 1 minus sine x, and then 1 plus sine x. And I still have 1 plus sine x on the bottom. Okay? Now you can see something that I can cancel out. What I can cancel out is 1 plus sine x and 1 plus sine x. That makes our life a lot easier since we're not dealing with a fraction anymore. Okay, so I'm going to bring this up. So now I have 1 that was on the outside minus 1 minus sine x, which is all that is left from that fraction. Okay, this negative is going to go to both terms. So I'm going to end up with 1 minus 1, and then again this turns into a positive, plus sine x. Okay, both of these will end up canceling out. 1 minus 1 is 0, so I do end up proving that this is equivalent to sine x, or my right-hand side. Okay, so this one is proven. Alright, number 11, I've got cotangent x plus tangent x is identical to cosecant x and secant x. Alright. Now it doesn't. I don't think it matters which side you pick. I would choose. Personally, I chose this this left side. So I'm proving this left side is equal to or identical to my right side. Okay. Now if you remember cotangent, you know that identity already. Okay? And tangent also has an identity that you should be familiar with. Okay? Let's do tangent first, right? Tangent. Okay, I can change tangent into sine over cosine. Right? That's an identity that most of you guys are familiar with. Well, if that's what tangent is equal to, cotangent is just the inverse of that. That would be cos x over sine x. Okay? Now you're probably wondering, what can I do now? Okay? What I can do now is basically add these fractions together. I cannot add them at this moment since they have different denominators. Like for example, if I have 1 over 2 plus 1 over 3, I can't add those yet until I've changed the denominator, which I would basically do by finding my my greatest common my least common multiple. So I would multiply this side by 3, multiply this side by 3, or multiply this side by 2, this side by 2 to make sure that this and this have the same denominator. That way 3 over 6 plus 2 over 6, I could find out that's actually 5 over 6. Okay? That's exactly what I'm doing here. I have to change the denominator, and then, and only then, can I actually add them where they're the same denominator. So I'm going to multiply by cos x here, cos x here, because I'm looking for sine and cosine to be in the denominator. I'm going to multiply here by sine x and sine x. Okay, and at this point I can start adding these together because they have the same denominator, but I'll make sure I show those steps. Alright, so I've got cosine squared up top. Again, cosine times cosine is just cosine squared. And I have sine x times cosine x. And I also have this sine times sine is just simply sine squared x. And then on the bottom, that's of course the same like we wanted. Okay, now I can add these together. Why can I add these together? Because they have the same denominator. Okay, I'm going to have sine squared x, I'll put that first, and then cosine squared x all over sine x over cos x. Okay, now this should look very familiar because this is an identity that is probably most frequent. Okay, sine squared x plus cosine squared x is equivalent to 1. Okay, that's one of your Pythagorean theorem identities. So I know that this is equivalent to 1 in your numerator, and I have sine x times cosine x in my denominator. Okay, so here's what you could do now, right? Because again, here's my goal. I need to prove that it's identical to cosecant and secant. Okay, I can split these apart, right? I can split these apart and say 1 over sine x times 1 over cosine x. Again, that's just equivalent to what I have here. But I'm splitting them apart so I can, again, prove this identity and kind of show you, well, what's 1 over sine x? 1 over sine x is just simply cosecant x. 1 over cosine x is simply secant x. So I've proven this identity. So this is equivalent or identical to my right hand side. So this one is proven. So I'm going to skip some of these. I'm going to skip 12, 13, 14, 15. I'll go to 16. But again, if you need those problems, you can go ahead and look up the key. Okay. For 16, this is actually a pretty quick one. What you can do here is, again, I'm going to be working on this left-hand side, proving that's equivalent to tan squared x. What you can simply do is, you can simply just factor out sine squared x, right? Because notice sine squared x is here. It's in both your terms, okay? And I'm going to end that with once I factor that out, I'll end up having 1 and then plus tan squared. Okay. Now if you remember, this is also one of your identities. Okay. This is equivalent to secant squared. So now I have sine squared x. And again, this is equivalent to secant squared x. Okay. Again, try to change as much as possible into sine and cosine, so you can. It makes finding identities a lot easier. I can also change this into what? I can change it into 1 over cos squared x. Okay. And then I simply have sine squared x over cosine squared x, which again, that's one of your identities that you should remember. That is equivalent to tan squared x, which is exactly what I have on this right side. So again, this is proven to my right hand side. Okay, so that's number 16. Alright, 17. Both these sides are equally complicated. Okay, I'm going to choose the right side and help prove that's identical to my left side. Secant squared x minus cosecant squared x. Again, secant squared x, you know one of those identities already. That's equivalent to 1 minus, it's tan squared x plus 1. So I'm going to say tan squared x plus 1. I'm replacing that for secant squared x. And then, of course, I have cosecant squared x minus 1. Well, I can replace this with what? Right? I can replace this with 1 over sine squared x. Okay? Okay, let me simplify this just a little bit. I have tan squared x plus 1 minus 1 minus sine squared x. Okay? Now what I can do here is, let's add these together. Okay? Or in this case, subtract. What I can do to 1, I can change that to sine squared x over sine squared x, right? That's equivalent to 1. Okay? Again, I don't like too many terms in within this expression. I need to simplify this as much as I can. So I'm not doing anything to tan squared x. I'm simply changing 1 into sine squared x over sine squared x, and then minus 1 over sine squared x. Okay? Alright, so here's what I can do. Again, these are the same denominator. Okay, I can put that fraction together. So I have tan squared x plus sine squared x minus 1 over sine squared x. Okay. Alright. What I can do now, again, there might be different ways to do this. What I can do now is, again, you actually know one of these identities. Okay. For example, you know sine squared x plus cosine squared x is equal to 1, right? Well, this kind of reminds me of that identity. To find what this is actually equivalent to, what I can do is try to have this in terms of what that identity actually means. Okay? So if I subtract cosine squared x and bring this one over to the other side, I'll end up having sine squared x minus 1 is equal to negative cosine squared x. Well, now I know sine squared x minus 1 is equivalent to that. Right? So I can kind of use that to my advantage to make this a bit simpler. Since, again, if I have cosine up here, that might help me to get this cotan in the same process. Okay? Alright, so I know I'm replacing that with negative cosine squared x. Okay, so what I have is tan squared x, and I'm replacing that with negative cosine squared x over sine squared x. Okay, now this is negative. So what I can do, again, cosine squared x over sine squared x, again, that is equivalent to cotangent. So what I have now is tan squared x. Again, that negative and that plus is just going to be a negative. And then minus cotangent squared x. Okay, so I've proved this identity. This is equivalent to my left-hand side. So this one is proven. Okay.